So in this section, we're going to be solving quadratic equations by factoring. Before we can do that, we need to first look at what's called the zero factor property. It says that if a times b is 0, then either a must equal 0 or b must equal 0. So if we think back to our multiplication tables, the only time we ever multiplied two numbers together and got a product of 0 was when one of those two numbers was 0 to begin with. So if something times something is 0, one of those factors has to be 0. So let's look at an example where we have the quantity x minus 7 multiplied to x plus 2 set equal to 0. Again, in using this property, if something times something is 0, one of those factors has to be 0. So either x minus 7 must equal 0, or this other factor, x plus 2, must equal 0. One of them has got to be 0 if they're going to multiply to get a 0. So what we have now is we have two linear equations, which should now be easier for us to solve. We want to isolate x. We want to get x by itself. So for this first equation, all I have to do is move 7 to the right. So I'm going to add 7 to both sides, and that would give me x equals a positive 7. Over on this side, I've got x plus 2 equals 0. I want to move that 2 to the other side, so I'm subtracting 2 from both sides, and I get x equals negative 2. So I have two answers for this equation. I have x equals positive 7 and x equals negative 2. Now, if I want to check my solution, I can always plug my answers back in. Let's try x equals 7 just to verify that that solution really does work. So wherever I see an x up in the original equation, I'm going to plug a 7 in. So let's say x is 7. What's 7 minus 7? That would give us a 0. What's 7 plus 2? That would give us a 9. And we know that 0 times 9 really is 0. So that's true. So I know that 7 is a valid solution. I can also check the negative 2. Negative 2 minus 7 would be negative 9. Negative 2 plus 2 would be 0. And negative 9 times 0 is also 0. And you could try any other value for x. Nothing else is going to work. Nothing else will give us a product of 0. Just as an example, what if I tried the number 1? 1 minus 7 is negative 6. 1 plus 2 is 3, and when I multiply negative 6 times 3, I don't get 0, I get negative 18. So anything other than 7 or negative 2, any other values for x won't cut it, won't solve this equation. All right, let's look at another example. Let's now look at x minus 10 multiplied to 3x plus 1 equals 0. Again, looking at the property that says if something times something is 0, one of those factors has got to be 0. So in this case, if x minus 10 times 3x plus 1 is 0, one of those factors has to be 0. So either x minus 10 equals 0, or that 3x plus 1 must equal 0. One of those factors has to be 0. Again, we now have two linear equations, so they should be quick for us to solve. We want to get x by itself. So for this first one, I'm sending that 10 to the other side, and I get x equals positive 10. For this other equation, I've got a couple steps. First, I need to send the 1 over to the right. So I'll subtract 1 from both sides. That gives me a 3x equals negative 1. And then to isolate the x, I'll divide both sides by that 3. I get x equals negative 1/3. So again, I get two solutions for x. I have a 10 and I have a negative 1/3. And again, if you wanted to, you could plug those in for x. You can check your answer. These are the only two values for x that would cause this product to become 0. So those are our two solutions. We'll look at another one. Let's do x times the quantity 4x minus 3 equals 0. Again, we have something times something equals 0. One of those factors has to be 0. So either this x is 0 or this 4x minus 3 is 0. One of them's got to be 0. In this first equation, x is already solved for. X is already by itself, so that one's done. But for this second linear equation, we have some work to do to get the x by itself. First, we need to move the 3 over, so we'll add 3 to both sides. And then to get that x isolated, we'll divide both sides by 4, and we get x equals 3/4. Again, we're getting two solutions for this equation. These are the two values for x that if you plugged them in for x, you would get a product that equaled 0. Now, what those last three examples all had in common is I had two factors I was multiplying together. I said something times something is 0. And when I had two factors, I was getting two answers or two solutions each time. I want to look at an example now where I actually have more than two factors and see what happens for the solutions here. So let's look at an example. 4 times x plus 1 times 2x plus 3 equals 0. In this example, I actually have three factors. I have three things that are getting multiplied together. I've got the 4 times the x plus 1 times the 2x plus 3. So that's three separate factors, but again, all multiplying to 0. So one of those factors has to be 0. So if I take this 0 factor property literally, then if this times this times this is 0, either 4 equals 0, bear with me, or x plus 1 equals 0, or 2x plus 3 equals 0. Now, I'm not saying that all these things have to be true. I didn't say 4 equals 0 and this is 0 and this is 0. It's not that they're all 0. It's that one of them's got to be 0. But 4 can't be 0. 4 and 0 are not equivalent. So what happens here is the 4 equals 0. That factor of 4, this piece of the puzzle doesn't lead anywhere. This leads to a dead end. So I'm just going to cross that out and say that goes nowhere. However, these other two equations, we can solve for x and get a solution. So in this equation, I'm going to send the 1 to the right by subtracting it. X equals -1. For the last one, send the 3 to the right. So I get 2x equals -3. And then we'll divide by 2 to get x equals -3/2. So my first factor actually led nowhere. I got no solution out of that. It was a dead end. My second factor gave me a solution of x equals -1. My third factor gave me a solution of x equals -3/2. So most of the time, the number of factors or the number of pieces that we have, that should tell us how many solutions we have. But if one of those factors is just a plain constant number, a number that can't be equal to 0, then that piece leads nowhere. So in this case, while we did have three factors, this one led nowhere, but the other two led to solutions. So we only had two solutions from this one.